Okay, we've got calculation question number 6. And here it is. It's all about titrations today. So a student titrated 0.1 mole per dm cubed of HCl with 25 cm cubed samples of sodium hydroxide solution. So we've written out a reaction here. That arrow should be not there. So let's get rid of that real quickly. Hang on a second. There we go. And we'll put it up here. There we go. Okay, perfect. So here's the reaction. We've got HCl and NaOH, right? That's your sodium hydroxide and your HCl. They react together, and what you get is a neutralization reaction occurring. So you get water produced and a salt, which is sodium chloride. Now we've got some results of your experiment. Here's the titration, and there's your results. You've got titration number 1, 2, 3, and 4, and what volume of hydrochloric acid was actually added. What you've got to do is use the student's concordant results to work out the concentration of sodium hydroxide. And I put there as well, concordant results are within 0.1 cm cubed of each other. So that's very handy. Okay, jot this out, have a quick go, and we'll catch up in a few seconds to go through the answer. Righto, time to go through the answers then. So I've drawn a slightly different table this time to help you solve this question. So instead of having, mass, MR, moles, and ratio, this time what we've got is moles, concentration, and volume, right? We can put ratio underneath that as well. So let me just add that in now. So ratio underneath here. There we go. And now it's, a little bit different to the other one, but yeah, memorize this. It will really help you. So what we need to do is we've got a concentration up here, right? So let's do some highlighting. So we've got 0.1 mole per dm cubed of HCl. That's a concentration. So we've got to fill that into the concentration box for HCl. So that's 0.1. Perfect. So you've got that. Now, what else are we told here? We've got 25 cm cubed samples of sodium hydroxide. So we've got a volume for sodium hydroxide. However, did you see this little note here that the volume that you put in your table needs to be in dm cubed, not cm cubed, okay? So there's a very, very important conversion that you need to know, right? The conversion is this. To change your cm cubes into dm cubes, what you need to do is be dividing by 1,000, okay? So if you didn't know that, make sure you write it down now, store it in the brain, okay? So what we'll need to do is take that 25 over here and divide it by 1,000. There we go. So what's that going to give me? That's going to give me 0.025, and that's in dm cubed. So I'll put that there as a reminder of that, okay? So volume, dm cubed all the time, not cm cubed, okay? Done. Now, what do we need to do here? We've got a table, right? We've got a table of all the titration values that came out. So titration number 1, this is what they used. Titration number 2, this is what they used, etc., etc. Now, you were told something about concordant results. What are concordant results? Well, they're the ones that are within 0.1 centimeters cubed of each other. So what we need to do is have a look for our table and find out which values are within 0.1 centimeters cubed of each other. So having a look through here, I think that's going to be the result for titration number 2 and titration number 4, because those there are exactly within 0.1 of each other. So what do we do with this now? Well, what we do is we say that the correct amount of HCl to be adding is this and this. So 28.45 and 28.35. And what we want to do is take a mean of those, so like an average, right? So what we do is we call that a mean titer. So mean titer. So what we need to do is add those two together, 28.45, add that to 28.35 and divide that by 2. So if you do that, punch it all into your calculator, that will come out as 28.40. Now remember that there is in cm cubed. And remember, it's illegal to put that into your table because it's got to be in dm cubed. So what do you do to turn it into dm cubed? Divide it by 1,000. So if you divide that by 1,000, you get 0.0284. Okay, so that goes into your table, right? So 0.0284. And remember, that is in dm cubed. Okay, perfect. Got it. Now then, great formula over here, because that helps you to work out all of these problems with concentration and volume. So to work out moles, what you do is you take your concentration, which is a mole per dm cubed, and you multiply it by your volume, which is in dm cubed. okay? So if you look for your table, well, we've got that information for HCl over there. Bam. So all we need to do is just multiply those together. So get the calculator, start punching that in. That's going to come out as 0.00284 moles, okay? MOL. Done. Next thing, what's the ratio? Now the ratio between these species is 1 to 1 again, right? 1 HCl react with 1 NaOH. So I can put 1 to 1 over there. What does this tell me? Well, it tells me then that the number of moles of NaOH must be exactly the same. So we'll fill that in too. 0.00284 moles. There it is. Great. Now what do we need to do? Well, we need to work out the concentration of sodium hydroxide, right? So we'll need to do a little bit of rearranging with this equation here. So to find concentration, we'll need to take the volume and divide it, right, underneath the moles. So the rearranged version will be this. It will be concentration, which is in mole slash dm cubed, so mole per dm cubed, is going to equal the moles, which is MOL, that's your units, divided by volume. And remember, volume again is in dm cubed for the 100th time. So moles we've already got is 0.00284, so 0.00284, and we've got the volume in our table as well. Look at the volumes down here, 0.025, okay, so 0.025, that was dm cubed. So put that there, this was mole. So all we need to do now, punch it into calculator, and that will give us our concentration. So we've got 0.00284, divide that by 0.025, and that comes out as 0.1136. There we go, and that would be in mole per dm cubed. Perfect, so that's our concentration there. And that's the question all done. Simple. So not too bad there, not too bad. You've got to remember though, there's a couple of important formulas there, right? So the one that gives you moles, which is concentration times volume, and volume needs to be in dm cubed, right? So do not put it into that table if it's in cm cubed, only dm cubed. Okay, good. So more of these coming your way to practice. We'll catch up again very, very soon to solve another one of these problems. Until then, take care, practice your chemistry.